Believe it or not, today we're actually going to run something in AWS. We've hit the point where it's hard to really gain a visceral understanding of the security implications of what we're building without having some workloads to run. I mean, if you're running through CloudSlaw on the weekly schedule, you've been at this for over 6 months and you haven't run anything in AWS at all. We've just been setting things up. Today, we're going to fix that. We're going to run our first instance, which is the AWS term for a virtual machine. And the odds are high many, if not most of you, have already done this a zillion times. Don't worry, my plan is to use this to start to cover some of the security fundamentals and set the baseline for how we're going to use instances moving forward. If you ran through our IAM labs, you know that one of the single biggest sources of cloud security breaches is lost and exposed credentials. Everything we did from basic MFA to IAM Identity Center and IAM roles was to reduce this risk. Exposed instances sits right up there on the wall next to IAM abuse. If IAM is the Humpty Dumpty, instances and S3 buckets, we'll get to those later, are sitting right next to him waiting for their chance to slip and crack open your security program. Compromised instances are one of the top 3 cloud security risks. And when an instance is compromised, the most common form of abuse, at least today, is crypto mining. It turns out you can't make money mining Bitcoin unless somebody else is paying the electricity bill. There are 3 primary ways attackers compromise instances in your deployments. They can steal IAM credentials and use them to run their own instances in your account. Or they can trick you into running an image with their mining software already installed. And finally, they can use regular old network-based attacks to break into your instance and install their mining software. We've been learning about IAM defenses from the start, and today we'll take our first steps towards running secure instances to prevent the latter 2 attacks. And although I'm focusing on crypto mining because it's the most common attack instances these days, it certainly isn't the only one. And I recommend you go to the blog post and you read my Universal Cloud Threat Model paper written by myself and Chris Ferris that goes into all of those in more detail. First, let's cover a little bit of background. Instance is the term that's relatively unique to AWS. It refers to a running virtual machine. Instances are based on images. Images are like the CD-ROM disk us old people had to use to load up an operating system on a new computer. An image in AWS is a pre-configured operating system, which can include the base operating system as well as any additional configured software. I think you know where we're headed. Now, I like that AWS calls these instances since we're just running a copy, an instance of the image. And when we get deeper into workloads, you're going to learn about autoscale groups, which run and terminate instances based on the current demand. And that's why that term really fits pretty well over there. This is actually where the name Elastic Cloud Compute, or EC2, comes from. We can build things to expand and contract capacity by adding or removing instances based on demand. Instances, as I mentioned, are virtual machines, and virtualization allows us to run multiple operating systems at the same time on one computer. You can be on a Mac and run a full version of Windows on your desktop. We call the hardware for this the host, and the virtual machine is called the guest. And the software that allows this is called the hypervisor. There used to be a really big performance hit with virtualization in the early days, but a long time ago, the companies that made our CPUs added special hardware extensions just for virtualization to increase that performance. So when a guest operating system is running, it can actually access its slice of the shared hardware pretty directly. Now, I believe the AWS hypervisor these days is largely built into the hardware servers right now. It includes a bunch of security hardening that individual instances can never access anything from another instance. And this is a standard expectation for a hypervisor. Each instance, each VM, is totally isolated from the other ones. Now, this stands in contrast with containers where they share an operating system, and that makes that isolation harder. This whiteboard shows that a little bit. So what we have here is the actual physical server. So that's where all the hardware is running. And on top of that is running the hypervisor. So that's the software, which may be hardware in certain circumstances, that enables virtualization. And when an instance needs access to the CPU or the network or anything else, It runs on top of that hypervisor, which has those extensions that let it go right to the software. And when we want to run a new instance, we can do that using our library of images. So this sits over on the side here. And then there's a lot of different potential images inside, and each of those is a fully configured operating system that can become an instance. And one of the great things about platforms like AWS is if one instance, for example, is from one customer, blue, and the other is from another customer, green, they can never actually talk to each other. That's why I call an instance a hard security boundary. And there's a couple of different kinds of vulnerabilities we do worry about, like a guest to guest breach, which allows one instance or one VM to get to another one, or a guest to host security vulnerability, which would allow something in the guest operating system to actually access the host itself. And those are considered some of the most serious security vulnerabilities out there. They're very rare, and AWS is constantly making sure we don't have to worry about them. Now, this is all just backdrop. Today, we're going to learn how to choose a safe image and securely deploy and log into a non-public instance. And this knocks down those two big problems, the two most common ways that an attacker is going to come after you. I'm going to skip a ton of the detail just so we can get stuff running, but future labs are going to dig into more details. Before we finish, I want to highlight a few points. EC2 is the AWS service for running virtual machines. These VMs are called instances, and instances are based on images. Attackers like to hack in instances or get you to run an image with their malicious software already installed, and those are some of the most common real-world attacks that you can experience when you're running in the cloud. Multiple instances will run on the same physical server, but the hypervisor ensures that they can never see each other, and this is the biggest of Amazon's responsibilities in the shared responsibilities model. Our lab itself is pretty straightforward. The first thing we need to do is use CloudFormation to run a VPC. This week, it's going to come from one that I'm hosting just to make life easier. The second thing that we need to do is actually run the instance, and then we're going to log into it. We're going to use some special techniques for this to make sure everything is all nice and secure, and I'll explain it as we go. Let's go ahead and jump in. From your sign-in portal, log in, and then go to your test account 1 and administrator access. As I mentioned, we want to run our CloudFormation template. You'll probably see it right here, or type CloudFormation up above. Then go ahead and create stack. Choose an existing template, and the URL for this will be located in the lab blog post. Don't try to type this in. Just go to slaw.securosis.com, and this lab, go ahead and pull it out from there. Then click Next. For the name, let's just call it S.L.A.W. Whoops. Let's get out of that little window there, and S.L.A.W. Hit the wrong keys, strange things happen. And then scroll all the way down and click Next. We're not making changes on that page. Now on this one, we have to go ahead and click this. We're actually going to create a role, and that's going to be what allows us to log into our instance. So acknowledge that we're going to do that and click Submit. At this point, creation will take 3 to 5 minutes, so I'll go ahead and pause our video, and I'll keep hitting refresh. Okay, looks like my template has fully deployed. Now what we want to do is go to EC2, which is where we run our instances from. So type in EC2 and click EC2. Technically, the VPC service, all the API calls are in the EC2 domain as well, because that's where networking started, was as a place to run instances. But you don't care about the history lesson. Let's just go ahead and launch our first instance. We're going to give our instance the name of S.L.A.W. because I really lack any kind of creativity. Now you'll notice this is where we pick our image. So our Amazon machine image, or AMI, and Amazon Linux is the default one that's selected. And this is a good one for us to use. It has everything we need for our baseline, and it's frequently the one that I'll use when I'm building my own things, when I'm actually using instances. But here's an important point. You see that we have this quick start here, but look at this link, browse more AMIs. If I click on that, it brings me to a different page. And you can see the Quick Start AMIs, which is where we picked our Amazon Linux from, and there's sort of different versions here. My AMIs, which would be ones you built yourself, which we'll do in future labs. Marketplace AMIs, which are ones that are managed by third-party vendors that have gone through a vetting process. And then community AMIs, which anybody can deploy. These are the ones you want to be careful about. Never, ever, ever deploy a community AMI unless you know for sure the provenance, the origin of that AMI, and that you're not going to be introducing a vulnerability into your environment. All right, so let's go ahead and we'll just stick with our selection here and go select. Now, I'm going to click back on the quick start here just to make sure, yep, we're all lined up the way we want to be. Yeah, you don't have to do that. The selection we did before would work as well. Our instance type is T2 Micro, which is free tier eligible. Yay! Then we get to the key pair. We're not going to need a key pair. How are we going to log in? It's magic, and I'm going to show you later. And then we go to network settings. These are not the settings we want at all. Go ahead and click Edit under Network Settings. Now, we only have the one VPC, so that's correct, and we want to pick our S.L.A.W Private 1. S.L.A.W Private 2 would work, but let's all be consistent, and we'll pick S.L.A.W Private 1. That was created with our CloudFormation template. The auto assign IP address setting, if disabled, is fine, but we don't want to create a new security group. I actually included one in the template for you. So hit select existing security group, and we're going to go with S.L.A.W private security group, and we'll actually look at that security group while this is deploying. Or I could actually just click here and compare the security group rules. That's just to compare, so we're not going to go ahead and do that. We'll just select the security group we already have. And I'll show you in a minute what that looks like. Now, this part's really important. This is required for us to log in. Go to Advanced Details, click that down arrow. Go to IAM Instance Profile right there, and then click Select and SSM Client. This is what has the permissions so that we will be able to log into our instance. Once you click all of that, you can go ahead and launch instance. Okay, so the instance is booting up, and it does take time to boot up, just like any kind of computer or server that you've got. What I want to do quickly is click on EC2, and then we're going to look at our security group and double check that the settings are correct. So go to Security Groups. This should be familiar if you're following these in order. And you can see that we have our Cloud S.L.A.W Private, SG is the name of that security group. And it's got a weirder name there. Don't worry about that. That has to do with how security groups are presented in the console. If I click on the checkbox here, inbound rules, no inbound access. You're like, wait, you haven't given me a key to log in and we have no inbound access and this is still going to work? It should work, especially if our outbound access allows everything. And that's what we need to get this set up. Now, let's actually go to our instance and go to login. So go to Instances, and it looks like it's running. Now the status check says initializing. Let me hit refresh. I don't like to log in until it's past its status checks. I'm going to go ahead and pause. This should only take a minute or two. Once it's done, then we'll actually go ahead and log in. As I often find myself, I just kept hitting the refresh button here until we have status checks 2 of 2 passed. Then let's click the check mark. So I didn't have that clicked before when I blipped over, and we'll click that, and now we'll connect. Let me explain what's going on here. We are using something known as Session Manager. And Session Manager works because there is a small software agent installed on our instance. It is default installed with those Amazon Linux AMIs, which is why those work really well for things like our labs. That agent is communicating with the Systems Manager service, or the Session Manager part of it. That works because we put our instance in a security group with outbound internet access. Even though it's on a private subnet, that private subnet has a NAT gateway, which allows that to connect to the service itself. This eliminates the need for SSH keys. It ties into IAM. We are going to do a lab specifically on Session Manager, but for today, we just want to get it up and running because we need to be able to run instances so we can actually start playing around with our network security. Let's go ahead and click on Session Manager, and then click Connect. It's now connecting and I'm in. And if I do ls as a Linux command, that shows me the directory I'm in. That's it. We are connected. We have an instance up and running. It's running in a pretty secure setup. It's running in a private subnet. It can only communicate to the internet with a NAT gateway. There's no keys to manage. There's no credentials to manage because we're using Session Manager to log in. And this is based on an Amazon supported base image. So let's go back to everything I said before about the crypto mining and the networking and everything else. We're, again, not talking about IAM today. We're talking just about launching these things. But in this particular case, I have launched an instance that, one, is not accessible from the internet. This is only in a private subnet. And the only way to get to it is kind of through this special capability that Amazon has so we can log into it. And then two, it's based on a secure image. And I know that's secure because it's Amazon's responsibility in the shared responsibilities model to make sure that the images, the AMIs that they give us, don't have any backdoors. With all of that said, let's go clean up, and it's actually really easy going back into the console. First thing I'm going to do is close this window where I'm logged into the instance. By the way, feel free to play around with it and poke around. There's no reason not to, and we'll actually do some of that later. Then I have my instance here, and I'm going to go do instance state and terminate. Terminate is how you delete an instance. It deletes the instance and it deletes the storage volume behind the scenes. There's a whole bunch of stuff we haven't talked about with instances that we'll get to. So let's go ahead and click terminate and delete. Now it's started termination. It can take a little bit, so I'm going to hit the refresh button here. Usually this goes pretty quickly. You can see the instance state there is shutting down. I don't want to go to my next step of my cleanup until the instance is actually fully terminated. And let me hit refresh again. And now I'm going to pause. This usually goes within about 1 minute. It actually took less than a minute on my pause, and you can see that that instance is terminated. Now we want to clean everything out. So we're going to go back to CloudFormation. Click on it. Click on our stack that we created today and then go delete. Delete. Remember, if you don't do this, you're going to get charged for that NAT gateway. That's the only thing in there that will go ahead and that you'll go ahead and be charged for. If I hit refresh, let's see the status, delete in progress. And I'm going to hang in there and make sure that's fully deleted before we end the lab. And I didn't even need to hit the refresh button. It deleted everything out. We're back to where we started and we're all set. See you next week.